So one thing I want to point out here real quick is that this one's a little bit tougher. If we were to think about cosine inverse of minus 1/4, we'd be trying to find an angle where cosine theta is equal to minus 1/4. And minus 1/4 does not correspond actually to any of those common angles. While there is an x value on the unit circle of minus 1/4, again, it doesn't correspond to one of the common angles, so you can't find it on here. Okay. So let's see how we're going to fix this. And I've actually kind of wrote how we're going to fix this. Let's see here. So let cosine inverse of minus 1/4 equal theta. And so we haven't really done anything here. We're just saying call this thing theta. Okay, right? Cosine inverse gives you angles. Okay. Well, then is what that means is that cosine of theta is minus 1/4. Okay. And it also means, right, cosine is adjacent over hypotenuse. So we can make a little bit of a sketch here. So there's our initial side of our angle theta. Let's think about what quadrant theta should be in. So since we're thinking about cosine inverse here, okay, and we're thinking about a negative x value in some sense, right? Because cosine, actually, let's look at this other piece over here. I think it's easier to see from here. So cosine of theta is negative. So that means we must be in quadrants, right? 2 or 3. That's where cosine is going to be negative. But we also have to remember we have restricted theta here so that it is in quadrants 1 and 2, right? Cosine inverse can only give us angles in quadrants 1 and 2. So the only quadrant in common here for theta is this quadrant 2. So that must be the angle that theta lies in. And I'm going to try and sketch it. Okay. And as long as this angle's in the right quadrant, all our math should work out just fine, even if our picture is a little off here. Okay. So next on our list is to include this adjacent side and hypotenuse. Okay. So if I turn this into a triangle, I know that the adjacent side to our angle should be of length 1, and I know the hypotenuse should be of length 4. Okay. And one more thing, we're missing this side over here, and we might need that because tangent is equal to opposite over adjacent. Okay. So let's go ahead and compute that. We use our Pythagorean theorem. We have 1 squared, let's maybe call this leg here b. So 1 squared plus b squared is equal to 4 squared. And we'll go ahead and we'll solve for b. So b squared is equal to 16 minus 1, which is 15. And so that means b is equal to the square root of 15. Okay, so we have all the sides there. And I suppose if you even wanted to label the angle theta, you could. Theta should look something like this. And its reference angle would be this guy in here. Okay. So now we have everything that we need. Let me show you how we do. Tangent of cosine inverse of minus 1/4. You might remember we defined cosine inverse of minus 1/4 to equal theta, right? And I have a picture of theta over here, and it corresponds to this right triangle. So if I want to figure out what tangent of theta is, other than potentially the sign plus or minus, we know that tangent of theta should be the opposite side over the adjacent side, right? TOA. So I'll have this square root of 15 over 1. Now I just need to think about, is tangent negative or positive in quadrant 2. Okay. Well, since the x value is negative and the y is positive, if you do y over x, you'll get a negative. So I just need to make sure I have a negative sign here. And so our answer is minus the square root of 15. It wouldn't be a bad idea to try and mimic this exact process that we did here for the next one. And let me get it there. But yeah, I think it'd be worthwhile if you feel ready for it to pause the video and try out part D. So we are going to start off the exact same way. Let sine inverse of 2/3 equal theta. And so what this tells us is that sine, let me write that a little bit nicer, tells us that sine of theta is equal to 2/3. Okay. And let's think about what quadrant this would put us in. Well, sine inverse only outputs angles in between minus pi over 2 and pi over 2. And another thing to think about here is if we were just maybe thinking about sine for a second. Well, sine is positive in quadrants 1 and 2. Okay. So in quadrant 2, we are not between minus pi over 2 and pi over 2. So it's got to be quadrant 1. This has to be a quadrant 1 angle. Let me get rid of some of this. So let's go ahead and sketch our angle in quadrant 1. And again, as long as we sketch the angle in the correct quadrant, even if things aren't to scale here, the math will all work out. Okay. Now let's make a triangle out of this. And let me use a different color. Let's see here. There we go. So here's the triangle. And actually, this is one of those times where we actually don't have to find a reference angle because our angle to begin with is acute. Okay. Well, sine of theta is opposite over hypotenuse, right? So opposite over hypotenuse. So let's fill in these side lengths. The opposite side should be of length 2 while the hypotenuse is 3. And we just need to find this missing side here. Okay. Well, if we're going to do that, we need to use our Pythagorean theorem. So we have a squared plus 2 squared equals 3 squared. So that means that a squared is equal to 9 minus 4, which is 5. So that means that this missing side here is of length square root of 5. All right, next, we can actually start to finish this problem. We started off, right, with secant of sine inverse of 2/3, which we defined sine inverse of 2/3 to be theta. So we get secant of theta. And all 6 of our trig functions are positive in the first quadrant. Okay, so I don't have to worry about the sign here. Okay. I just need to compute secant of theta. Well, remember, secant of theta is the reciprocal of cosine theta, which is adjacent over hypotenuse. So what we want is hypotenuse over adjacent for secant. Okay, so hypotenuse is length 3, and the the hypotenuse is length 3, and the adjacent side is the square root of 5. Okay. And the only other thing we could do with this if we wanted to is rationalize the denominator. Okay. But I do want to write in here where two of those numbers came from, even though we said it. I just want to point out this was the hypotenuse, and this was the adjacent side. And then we have one more to do here. Okay. And this one might be a little bit more confusing because we have x in here. Okay. Let's see how we might want to approach this one. Well, let's think about that 2x in there for a second. Well, it must be positive because x is greater than 0. We're going to need to think about that here in a minute. Okay. But we can still start off in the same fashion. Let cosine inverse of 2x equal theta. Then that tells you that cosine of theta is equal to 2x. But no, I want to use the fact that cosine of theta is adjacent over hypotenuse. So why don't we just write it as 2x over 1? And now we can sketch a triangle out of this. But we should go back to this x greater than 0 thing. So if cosine of theta is equal to a positive number, we know that the angle must be either in quadrant 1, right, or quadrant 4. That's where our x values would be positive. Okay. Now the next thing is that cosine inverse is restricted to quadrants 2 and 1, right? It has to be cosine inverse gives you angles between 0 and pi. So it can't be this one. We have to be in the first quadrant again. So let's sketch that first quadrant angle. And we're going to make a triangle out of this. All right, so again, cosine theta is equal to the adjacent side length over the hypotenuse side length. So I'm going to put on the adjacent side a 2x, and I'll put on the hypotenuse a 1. And so we can just use our Pythagorean theorem to find this missing side over here. So we'll have 2x squared plus b squared is equal to 1 squared. And we're just going to solve for b here now. So you have b squared is equal to 1 minus, and if you square 1, you get 1, and if you square 2x, you get 4x squared. So this missing side length here is just the square root of 1 minus 4x squared. All right, and now we have enough to finish this. Okay. So we know sine of cosine inverse of 2x, we define to be sine of theta. And since we're a first quadrant angle, we know that sine of theta should be positive. And sine of theta is opposite over hypotenuse, so we're going to have the square root of 1 minus 4x squared all over 1. Okay. And that is it. It's just the square root of 1 minus 4x squared.